sort of like real world problem. Basically, it gives you this function. It's a piecewise function. It's defined in pieces, and it's talking about that it's the total accumulated revenue of a given company. So this company makes however much money after T years. Okay, it's measured in millions of dollars, and this is the revenue function for the company. Now, it basically wants us to determine what happens as time goes on forever, as the limit of t goes to infinity of r of t. Well, you're definitely only going to be using this piece for that, and you basically want to ask yourself what happens to limit as t goes to infinity of this piece. And again, there's a rule. This function as t goes to infinity is a rational function. This is a rational function. This is a polynomial. This bottom part is a polynomial. And that makes the division of two polynomials is known as a rational function. And with rational functions, as you go towards infinity in either direction, the highest exponents will pretty much tell you everything. So the highest exponent on the top is 2, and the highest exponent on the bottom is 2. And now in this case they're equal. But there's really, for rational functions, only 3 cases: that they're equal, as they are in this one. The top exponent, the highest exponent, is greater than the bottom, in which case it does not exist, this limit. And it could be the reverse, that this could be a 2 and then this could be a 3, and the highest exponent on the bottom is greater than the top. In that case, it tends towards 0. And then in the case where they're equal, like it is in this case, what you do here is that this is 2, this is 2, so it just simply becomes the division of the coefficients next to those highest exponents. So in this case, it's 100 divided by 1, which is just 100. So this limit as t goes to infinity of r of t equals 100. Now, explain the meaning of the limit as t goes to infinity of r of t in the context of this problem. It just means that as time goes on, the revenue of this company will never be $100 million or greater than $100 million. It will never get past $100 million. So as the years go on, as time goes on, the revenue will get closer and closer to 100 million. The revenue, or the total revenue, let's say total to make it clear, the total revenue will get closer and closer to $100 million, but never equal. That's basically the explanation of this in the context of the problem. Now it's asking, is the function continuous at t equals 20? And for this, you want to kind of just keep in mind, or just have it right away, your definition of continuity. So B, is it continuous? That would mean that limit as t goes to 20 of r of t should equal r of 20. And that would imply that r is continuous at t equals 20. Now, in order to determine whether this is true or false, you need to evaluate this limit. And evaluating this limit, you want to consider 2 pieces. You want to consider the left-hand limit. You're determining whether this is true. You don't know. Okay, if this is true, then it is continuous. If it's not, then it's not continuous. So limit as t goes to 20 from the left of r of t. And you want to investigate the limit as t goes to 20 from the right of r of t. And ideally, both of these equal whatever r of 20 is. Now, r of 20, I could plug into this and I could get that value and so forth, but let's do that at the end. see what we get for these limit values. So the limit as t goes to 20 from the left means that I want to use this function. So as t gets closer and closer to 20 from this side, this inner value, if we do this, and it'll just follow from limit laws that there's nothing wrong with me sort of taking t to be closer and closer to 20, but lower and lower, and you'll see that this square root value is, or the inside of the square root value is getting closer and closer to 1, which means that the square root value is getting closer and closer to 1, and then 1 times 41 is just 41. So this left-hand limit equals 41. Now I want to check, does this right-hand limit, as I get closer and closer to 20 from the other side. And in this case, again, this is a rational function. A rational function is continuous for where it's defined. So I could just plug in 20 into this and see what I get. So let's see, 100. 20 squared is 400 plus 1,000 over 20 squared is 400 plus 600 is 1,000 again. This is going to be equal to, how many zeros can I cancel? Well, from the top I can factor out at least 100. 4 plus 10 over 1,000. These two zeros will cancel. I'm left with 14 divided by 10. Did I do this correctly? Something's not right. What did I not do right? 20, 400. Oh, this is 400. Sorry about that. Yep, because I factored out 100, so I'm left with a still full 400. So this is 410 over 10, which is 41. And this right-hand limit equals 41. So they both equal 41, so this limit exists equals 41. Now I need to check r of 20. Is that 41? Yeah, because it's defined for this bottom piece right here. R of 20, I use that bottom piece, and I just plug in and I got 41 again. So it is indeed continuous at 20, and you could say it's continuous at 20 because this limit as t goes to 20 of r of t equals r of 20. And you could show that the right-hand limit and the left-hand limit are equal with what I just did here. That guarantees that this limit is equal to 41, and then r of 20, you can just plug in and do that work. Answer. Okay. Now, the last one. It's asking basically that you have its total accumulated expenses up to time t is modeled by the function e defined by this here. And what we have here is that they want to know if this is the expense function, and we have our revenue function right here. We want to know if the total accumulated profit. So I'm going to write a function for total accumulated profit. P of t is equal to, which is the total accumulated profit, and they actually even give it to you, is equal to r of t minus e of t. And they want to know if it equals 0 at any point from t being 0 to 5. And what you need to do here is you need to use the intermediate value theorem. I'm going to draw a picture of what this looks like so you guys can see, but let's just go through the hypotheses, or what conditions you need to have in order to use the intermediate value theorem. Basically, p needs to be a continuous function from 0 to 5. R of t is a continuous function. E of t is a continuous function from 0 to 5. And the subtraction of two continuous functions is a continuous function. So I have that P of t is continuous. And I need that piece. Now the next thing that I show is that P of 0, right, one endpoint of my interval, P of 0, is going to be equal to whatever R of 0 is, minus E of 0, because that's my definition of P. So R of 0, if I plug in 0 here, 0 times 0 over 0 over 20 is 0. The square root of 0 is 0. 0 times 41 is 0. Minus e of 0. E of 0 is going to give me 0 plus 4 inside here. So I get log base 2 of 4, which is 2. Times 3, 6. So I'm going to get that p of 0 equals negative 6, which is less than 0. And now I'm going to find out what p of 5 is, the other endpoint here, p of 5. And again, that's r of 5 minus e of 5. Now, r of 5 is 1/4, the square root of 1/4, which is 1/2. So this is 41 over 2 minus e of 5 is going to be 60, 64. Log base 2 of 64 is 6. And then that's 18. And now I don't know what this is, but whatever 18 over 1 is going to be what? 36? 36 over 2? Yeah, 36 over 2. And 41 over 2 minus 36 over 2 is 5 over 2. And the key thing here is that 5 over 2 is greater than 0. So I basically have this inequality. I have that p of 0 is less than 0, and p of 5 is greater than 0. Now, if you graph this to illustrate what the intermediate value theorem says and to see how it all makes sense, right? If I do this little sketch over here, if I may, let's do it in a different color. Let's there we go. Okay. And let's this, right? Or better, let's move it up so I have a negative value. And now let's change the color again. And you see p of 0 is some negative value. P of 0 is some negative value. It's saying p of 0 is negative 6, so this is negative 6 over here. And then p of 5 is some positive value, 5 over 2, 2.5, let's say up there. And I know p is continuous. So what must happen? If I'm going to go from this point to this point, there must be some value where p of t is 0. That's what it's asking. It's asking, is there a time t between 0 and 5 for which the total accumulated profit is 0? Is there a value for total accumulated profit is p of t? So is there a time t where p of t is 0? And there must be by the intermediate value theorem. And the way you could write it out nice and neat, everything to summarize, if I just kind of box this out, I could say, in green, I could say since. Okay, you want to make sure you write down the conditions for intermediate value theorem. P of t is continuous and you have that inequality right there. P of 0 is less than 0 and p of 5 is greater than 0. And by, since p of t is continuous and this is the case by intermediate value theorem, IVT, there must exist a t between 0 and 5 with p of t equal to 0.